Good morning. It's the 23rd of June 2014, and this, guys, is a breaking alert. Just recently, Swarm have released their magnetic mapping of the Earth. That was, if you remember, those 3 aircraft we've seen being assembled to get a 3D image of the magnetic field of the Earth. And I'm not surprised now. They went all out to build those 3 spacecraft. In short, I want to just get it off my chest, guys. And I don't know whether they have released the information yet, or they are preparing to, or they're not going to say a word. What we are looking at in this diagram here, or the imagery that has been produced by Swarm, is the magnetic field of the Earth. Now, someone that hasn't messed around with a lot of magnets, and I mean, I've got tens of years, playing about with these things, so I realised as soon as what I was looking at, what was taking place, and it answers pretty much everything. Now I'm going to be honest, this pole shift was playing out in a different way in my mind, but when I seen this, I'm going to show you the results of the experimentation as well, because yes, guys, I've recreated that magnetic field, what we're looking at, and we've got some very interesting results. And it's like I say, it's a no wonder what we've been watching with the magnetic North Pole migrate across the northern hemisphere, as it has done for the last 100 years, and did so more rapidly in the last, say, 2 decades, 20 years, position the North Pole where it has. So here is the big news, guys. At the present time, we have a double North Pole and a double South Pole, and we can clearly see that with the concentrations of those magnetic areas increasing in strength, both on the right northern hemisphere and on the left northern hemisphere. It's quite clearly demonstrated in the experiment that is the case, and that is why the North Pole is still being picked up at a single point in the Atlantic Ocean, the North Atlantic Ocean over the Arctic region here, because you've got a double North Pole at the northern hemisphere and a double South Pole at the southern hemisphere. Again, on the southern hemisphere, you can see the breaking apart of the 2 poles. Now, if I was to put a compass here, right in the centre, on the equator of the Earth, it would point in between the 2 poles, because they're still relatively balanced, although it is quite clearly made out on this diagram that there is a stronger pole on the one side of both, on the northern hemisphere and on the southern hemisphere, and both right positioned on the map that we're looking at. So what happens when you get 2 North Poles is they separate. They literally push each other away. And as we can see also with magnets, is that the opposites attract each other, and we can see the lower right dipole stretching up over the equator towards the northern dipole. Now, in the experiment which I concluded, it shows that when they dislocate, something very unique happens. The right hand side dipole at the north right connects with the lower one, first of all, because opposites attract, and it does so because the 2 North Poles are pushing each other away because they're like in polarity. But what happened in the experiment more than once is that this North Pole, when these 2 connected and separated from this North Pole, it shot straight over to this lower left hand pole as well. Now, what some people, and I dare say some scientists, might be looking at here is a separation, right? And we will have a double pole either side, in other words. And I'm not saying that this can't be outruled, because I'm surprised that we haven't had separation of these poles already, and when they do, remember what I said, poles don't like to be in weak field lines very long, so that's where all the action happens. And I believe, looking at this map, we are incredibly on top of that time when something is likely to take place with this. Now there's a few analogies I want to run by you with what could possibly happen. Now the first one is, we get the dislocation first of all of the two north poles because they're repelling against each other, and when that happens it attracts the first south pole it can do to it to, satisfy its magnetic makeup. Remember, magnets never exist in monopoles, so they will connect. My guess is what's taking place here is the south pole's lurching up towards the north pole. It will connect with that. Once it does, it will snap off its bond with its other north pole, and like has happened in the experiment, this right hand north pole will connect with the south left pole down the bottom there. That's one analogy. That's what's happened in the experiment. What didn't happen in the experiment is probably what scientists are looking at right now and pondering might be the case. We get two poles, these two connect together, it breaks off, and this one lurches over to that one, and the both poles end up at 90 degrees from where they are now. So these two will join together, forming at 90 degrees here from where the original position is, relocating the north pole to here. The south pole will relocate to here when these two come together, and we will have weak field lines running right down the centre. Now I've got a problem with that, because if we orbit our sun on a magnetic torque rotation, and I'll show you that in an experiment. Basically I hold a magnet over a magnet on a ball, and when I tilt the above magnet it causes rotation, and I can basically, by moving the above magnet, I can get that magnet, the lower one, to follow it, and I believe that's how the interaction works with our orbit. But the only thing is with that is when the poles turn 90 degrees, the planet has got to also rotate physically on its axis 90 degrees in order to maintain that torque rotation. I believe all these things don't happen in the blink of an eye as well, and I think that's why these poles haven't separated already, because we're talking about a very large inertia here. There's a lot of things taking place, and with large things they happen slowly. Like I say, the last time the Earth went through its magnetic reversal, it was recorded that it did so over around about 3 weeks in time, and there was a gradual shifting, if you was looking at your compass, of that needle over. So let's get into the experiments, because what I've done is I've built the configuration of what we're looking at here, and I've also used the magnetic viewer so that you can see it is as it is on this Earth, right? So what we've done, because what I've done here is, by looking at this I can see that there is a stronger pole on the one side of the northern hemisphere. Remember, these two are both north poles, and there is likewise a stronger pole on the southern hemisphere. So what I've did is I've configured 2 magnets for this side, 2 magnets for this side, 1 magnet for this side, and 1 magnet for this side, giving an overall north pole and giving the overall south pole. Now the interesting thing is here is, because I've done that, is that we've got when we position the compass, which I'll show you in the experiment, on the the prototype or the model that we're using, we get the north pole slightly leaning off towards the stronger fields, and that is again what seems to be happening with the Earth, because we've seen this pole migrate across from Canada right over to almost in the middle of the Atlantic right now, heading towards Siberia. So what I'm saying is, even on the model, it predicts where it recreates the actual position of where the pole is. So that fits very well. The other thing is is if you look at these weak field lines in the centre here of these both areas, is that it almost forms a diamond pattern. And in the model that we've got the same, a diamond pattern. Now remember, I'm having to use magnets all of a very similar strength, and I could have really done with just half a magnet on the right hand side and half a magnet on the left hand side to bring out this flaring on the southern hemisphere. But I think it's close enough, guys, because when you look at the magnetic field viewer, when I place it over those magnets, you'll see the same as what I did, and it almost replicates what we're looking at on this screen. The big news here, guys, is that we have 4 poles currently on the Earth right now, and they are in the not too distant future about to separate because of the the attractions and repulsions associated with magnetic dipoles. So I'm going to now switch over to the camera, and I'll just point out that and I'll narrate over it for you. So what we've got here, guys, on the left hand side we've got the replication of the model of the magnetic pattern, and you can see the magnetic viewer over there, which clearly is showing the 2 north poles, one here and one here, and the 2 south poles, one there and one there. Now under this magnetic viewer there is 2 magnets with a north polarity pointing towards the top of the picture, and there is 2 magnets on the southern half pointing towards the bottom of the picture. There is a single magnet with a north polarity pointing up, and a signal magnet here on the left side pointing down, and that gives an overall north magnetic field and an overall south magnetic field. However, because there's 2 magnets on both the right hand side, north and south, we're getting slightly more strength in the field, and that represents what we've got here over on the right, with the stronger magnetic field on the northern right hand side and the southern right hand side as well. What you can clearly see in between the 2 poles here is a weakening of or a separation of the strength, and you can see it has created almost like a diamond pattern here, and that is exactly what we've got here, and that is what you get when you get a quadpole magnetic anomaly, and that is what we've got. Now the reason why we're getting an overall north pole still, and the compasses are pointing north and south at the moment, is because they haven't fractured, but they will do, because you can quite clearly see 2 north poles, one slightly stronger than the other one, and what you get with polarities is a repulsion, and what you get with opposites is that they attract each other, and that is why I believe this southern one is lurching up towards the equator, towards this stronger pole. And it is in the experiment that I've done a bit later on. If I just run this so you can see the magnets underneath the film, you can see it's quite a good example of what we've got on the right hand side of the screen with swarms data. I'm just pointing out here with a pencil the individual north poles. Now they're both at the northern hemisphere, both of those poles are north, and both at the south pole polarity. Remember, the ones on the right are more stronger than the ones on the left, and that is because we've got 2 magnets on the right, 2 on the one, and only 1 on the left. But here's what I've had to do. Now I'll just stop the video here. You can see I've used some sticky tape to hold these together, and the reason why I've done that is because you can place these 2 nuts here together. I've had to use the iron. I think it's a good representation again, because inside the core of the Earth we have a big ball of iron, and the magnetic polarity is attracted to that, and that's how I'm able to stick these magnets together in that configuration. But what you can see is a slight separation there. Now, like I said, if I stuck them together, they would hold, but very weakly. Now, I think I've overcharged the right hand side just slightly, because otherwise we'd have a lot more on the right hand side of Swarm's data. We'd have a lot more strength in the field than what he's actually showing. I would say perhaps if I'd have used just half of the magnets, so I used 1.5 magnets, we would have got a better example, and that these wouldn't have tried to force themselves apart as much as they have. But there's a good outcome to this. You see, I could put the array without the sticky tape holding them together on the table, but the slightest knock would cause this to happen. These two magnets here would click to these two, and then it would spin round and attach to this magnet. And I thought that it was a one-off at first, but it did it 3 or 4 times, and I'm thinking it must be the nature in the way poles separate, and I think it is likely to be the case. So on the Swarm's data we can see the one pole at the south coming up over the equator, and that is because it's oppositely charged to this pole here. And you know, I think at some point in the near distant future, guys, what we're going to see is an uncoupling of the second north pole that we have at the moment and an attachment to this large south pole. So these two here on the right hand side are going to come together. These two are going to fracture, and we can see that happening in the field lines, because we're starting to see emerge weak field lines in between these two densely, if you like, charged north poles. So it will be likely that when these two attract or get within a vicinity where they do clamp together, it will fracture at that point, these two north poles, because they remember, two north poles will push each other away, and then what we'll see is what we've seen in the experiment, where now these are all joined together, there's a separation, and there'll be an attraction from here to there, and a discoupling of this one. Maybe at some point, you know, they will all clink together. So I'm not saying we'll get a monopole, but what we will do is get the magnetic field line up where they join each other, north on south, north on south. And you know, the outcome of that when they do join up is a permanent one north pole and a permanent south pole. Now, it looks to me that the positions of the new north pole from the experiments I concluded here, right, will end up at 90 degrees rotation to the west. So your north pole is going to be at 90 degrees somewhere here on the equator where it is now, and your new south pole is going to end up somewhere there. And it is on the next experiment. I just want to run the end of this just in case there's something I've missed. So I'm just demonstrating now that we've got those two stronger fields on the north and south on the right hand side, like we have on Swarm's data, and we've got the weaker ones on the left hand side, both north and south. The other important thing is here, guys, is did you see where the positioning of the compass is at the moment? Now, if we was to put the compass over onto Swarm's data, it would be indicating a magnetic pole somewhere close to Siberia. Even though I've put the compass slap bang in the centre of these two, the reason for that is because on this experiment we've loaded up the magnetic charge, if you like, or the gauze, in favour of a stronger field, both on the right and on the right side, both north and south. The reason why I did that was to replicate the larger fields on the right side of the northern hemisphere on Swarm's data and the right side on the southern hemisphere. The thing is that if we had put the compass over here now, it would be pointing somewhere in the region of these two poles, these two north poles. In fact, it'd be somewhere in the centre, and that is exactly where, when we look on where we've been positioning the North Pole, we find it to be. No coincidence there. Like I say, I didn't expect it to play out like this, and it was only when I seen this, if you remember when I was looking at the old magnetic map data that had been gathered together, I said there was 3 poles. It looked like the Earth at this time had a tripole. In fact, it's got a developing quad pole. We've got two north poles which will push each other away, and two south poles which will push each other away, and we're at the point at where it's about to do that, because we've got these two now stronger poles pulling each other together with their opposite charges. When they do click together, and they will go together, there will be a separation of the two north poles. These two will have now be one, a single, if you want, a conjoined magnet, giving a north and a south pole, which will attract, like in the experiment, this left and weaker south pole. They will come together, and then there'll be a recoupling of this north pole, the weaker north pole, in alignment with the configuration of magnets. It's like putting four magnets together now, north on south, and what we end up with when we look under the magnetic field viewer is a south pole and a north pole. This is how this is going to play out, guys, and it seems it'll do that because it's been readily doing it in the experiment. So, it all fits, is all I'm saying. It's I'm really excited about it, guys. We can see it's happening. It's happening right now. We knew it was happening gradually over the last 100 years. It was accelerating over the last, say, 10, 20 years to the point where it has. And now, because of swarms data, we're starting to see what really is causing it all, and how likely or how close we are to it really taking effect. And I can tell you this now, guys, it will have happened before your days are out on this planet. That's what I can say. Looking at this, when you see two north poles and a weak field line separating them, at some point they're going to become poles of their own, and they'll be in the weak field lines. We know they don't hang around in weak field lines. They'll be looking for their partner, which is the south pole, and lo and behold, one is arriving, or rapidly making its way up to it. So the cards are on the table. Everything seems to be happening. I'll just run the end of this video. So what I'm now showing you is that it is in line of those two, but you can see, because of the extra polarity we've given those other two magnets, we've made the needle flick off slightly to the right. If we look at where the magnetic pole is, we can see that is the case. And I'm just demonstrating now that both the magnets on the bottom are south polarity, and both the ones on the top are north polarity. So I've got it right. I'm just wondering whether those guys at Swarm have actually built a model so that they can see and understand a little bit more how these things are working. If not, I would recommend they do, because what they're going to find is the same thing I found with these magnets. They do stick together, but they're very weak, and that's an indication that we are close to something happening with the Earth's magnetic field right now. Now, I said we're close. What I mean by that is, what you've got to remember, guys, is this is a big planet. There's a big inertia. Things move very slow. What I'm just doing here, guys, I'll just finish off what I'm saying. Things move very slow. Therefore, that's why some scientists say it took 3 weeks for the magnetic pole to make a full 180 degrees movement and become north become south, or we had a magnetic flip, in other words. So don't expect it to happen in the blink of an eye, but we can clearly see it's happening right now. I'm just pointing out that there is 4 poles there, and we end up with the same pattern. That's the main thing, guys. The model is a fairly accurate representation of Swarm's data, and we can experiment with that. Again, we've got this area in the middle of the pole, and if we was to look at the back of the pole and the back of the Earth, we'd see another diamond forming there and there, and that would be the other half of the diamond that we're seeing here. So we've got the magnetic polarity pretty accurate, and we can see the fracturing of the 2 north poles, and yourself, like polarities won't stick together. It needs the opposites. So what's really nice about all this is with this data now, we can see what's happening, where it's happening, and how it's likely to take place from here on out. And what I'm doing is I'm just indicating here those blooms of the individual poles, and that at a glance you would think that this was just one north pole and this was one south pole, but the reality is that there's two individual poles in each magnet. Yes, they're both north-south facing, they're where they should be on the data that we're looking at, but nevertheless when you remove the magnetic viewing film you can see underneath that there is in fact two lots of magnets, and the right side is more powerful than the left side. Well, that's it, guys. Like I say, this is breaking news, and this is on the back of Swarm's data that's recently been released. We may be ahead of the game of Swarm. They may not have made a model yet of the representation of the data, so you've heard it firsthand. And even if they had, do you think you would have been given the privilege of seeing that data? So recently I've been doing a lot of videos, and I've got a workload building up. We've obviously the Newman motor that we're going to replicate, but we're going to do it in the reverse way. We're not going to have the magnetic shaft in the center spinning. We're going to actually have the coil spinning. So there's that to do. There's more experimentation on that configuration of magnets that we're looking at under that film to the left of the screen. And as I get it, guys, I will relate to you as I always do. Remember this: there are billions on this planet that are completely unaware as to what special times they are living in right now. They're unaware of the magnetic pole migration, and the last time that happened was 780,000 years ago, and we are here today, right now, to witness what actually takes place during that. Now, whatever's taking place on the inside of this Earth, which builds the magneto, which supplies the polarities to the dipoles both north and south, and in turn gives us a protective magnetosphere. Obviously, there is something happening within the core of the magneto that doesn't usually happen. Now, we don't know what that could lead to, whether this could spell a catastrophic event, or like NASA have said themselves, and that was the reason why they wouldn't come out with it, because they was unsure whether it's an ordinary magnetic anomaly or a catastrophic event. All is I was saying, guys, is there is no recorded history either way to say what will happen and what won't happen. So, guys, hold in there. It's not the end of the world, at least for the moment. There is things taking place as we speak, as most people go about their daily lives. I couldn't put my hand up and say, this is the end, but I couldn't equally say this is not the end, guys. And I don't want to come across as a fearmonger. What I'm trying to do is just expand the awareness of this phenomena that is taking place. Like I say, it isn't every day a generation gets to witness such a rare event. But by God, we are. And for me as a scientist, it's really exciting, and I want to be at the running forefront of the commentary on this, as I have been for the last at least 3 years. So, guys, try not to let it ruin your day. It is a big breakthrough we've made today. We understand what's going on, why the pole's where it is, why it's been migrating, what's been going on, what's likely now. We will develop in a more clearer picture, as I'm sure Swarm are themselves. This is gathering pace. More people are becoming aware of it gradually, day by day, and it is, as I said, the biggest story of this era. And I won't keep you any longer, guys. Enjoy the rest of your day, be safe, and always be prepared. Bye for now.